Hi guys. Today I'm going to go through homework 4. So it is my big mistake that I forgot to upload it on time. I made it in March, but just it slipped in my mind. I forgot to upload it at the time. So so my plan is, and also I understand you are busy with micro and macro and the combs. So I will just show you how to do this, I will like, you can think it as a kind of extended lecture. And what I expect from you is you can just follow what I do and just take a note and make it kind of like clean and submit as your answer. So of course it would be great if you can just try the questions by yourself and just submit your answers. That is also great. But the purpose of this lecture is to kind of save your time and minimize your time to spend on this homework in case if you have to spend more time to pass the combs, right? So uh, so in this video, I'm going to discuss question 1 from homework 4, right? And of course, before watching this video, please read the question carefully and think about how to solve this question, right? So and then listen to the video, okay? And another goal of this video is to show you how to handle leaks, right? You do not need to use leaks, but in case if you wanted to learn latex, but that's too complicated, that's too slow, then I recommend leaks. It is an editor based on latex, but much easier to handle. Okay, so let me start by showing leaks. So this is the first like an empty page on leaks. By the way, I will show you my setup. So like I put those toolbars here and there, and this is my customization, right? You may like add and subtract something, turn on and off based on what you want. But like this is my setup, so you can copy my setup if you want. That would be a good starting point, and then you can customize by yourself. Okay, so like see what is checked. And when you start a new document, I recommend you to go to the setting. First, I will show you how to change the font size and spacing and the margin. So font, like it should be simple. You don't need to touch it at all. Like I usually leave it as default, but now because I want to show you a large font, I change it to 12. But in your answer, like the default would be fine, like 10 would be fine. And layout, on text layout, you can change line spacing to 1/2 or double. I usually prefer 1/2. Double is too wide, single is too tight, so I prefer 1/2, so I will choose it. And you can just try if you want. You can just read and change what happened, but I almost never touch them, so I do not know exactly. And page layout, nothing special. If you wanted to make it more like fancy, you can change page style to fancy. I do that when I make an undergrad lecture note, but you don't need to. And page margins, default page margins are really wide. They are a huge margin, so it's a waste of paper. So I like a standard is 1 inch in top, bottom, inner and outer. But like you may just put 1 inch here, 1 inch here, or I would just put 2 centimeters or 3 centimeters, does not matter. But anyhow, the standard is kind of 1 inch for these first four, like top, bottom, left, right. But you may like choose 2 centimeters if you want. That's kind of basic setup. And as you know, in this leaks, there are two ways to type things. Like first, this is text mode. The first mode is text mode, and if you if you press Control M, then the mode is to math. It is math mode, right? So in the math, like it looks more like a math equation, right? So italic font, and I don't know how the what the difference is. I know. So math equations are usually typed as like math. So let's think about, for example, say x comma y, right? So this is how I type uh, the text, like uh, this is text mode and this is math mode. So by the way, in math mode, you cannot press space. Space is not allowed in math mode, so just be careful. This is math. And if you press Control Shift M, you are going to have a new line centered display, right? And if you want to make another line, Control Enter. If you press Control Enter, then you are going to see another. You can continue the equation like this. Okay. And if you right click the display, you can change like a number whole formula or number this line like this, right? Or if you do not like, if you only need the numbering only for the second line, then you have to choose number this line or number whole formula. It's up to you. Okay. Um, okay. Then if you want to input a theorem, like usually theorem should be here, right? Title, author, date. It's easy to see what happened. But I like usually you may want to include like theorem, assumption, definition, lemma, proof, things like that. That must be set up in here, document setting. You have to go to modules and go down. And what we are going to use is AMS mode, theorems of AMS. So AMS is American Mathematics Society, maybe. So first, there are three choices. So it's three basic packages, and like AMS just base, and AMS numbered by type within chapters, and the third is AMS numbered by type. So it doesn't matter. It's literally AMS like the default in the default, like theorem 1, assumption 2, assumption 3, theorem 4, like the numbering is shared by all like theorem, assumptions, definitions, all the objects. But if you want to change them, like you want to choose this. Okay, so double click or you can click add. So it is selected and then click OK. Then now you can see there is additional things like theorem, like corollary, lemma, proposition, conjecture, definition, example, blah, blah, blah. So these are like the things you want to do. Like for example, say theorem, this is theorem. Automatically, it changes the style, right? So then when you enter, theorem is continued. So to get out of the theorem style, you have to change it to standard. Then it's now it's standard. Additionally, I also recommend you to add extended module. But like because I chose number by type, you have to choose AMS extended with the same type, right? Same type. Okay. Then there are even more objects like no assumption, right? So this is assumption again. It changes the type. Anyhow, this is pretty much the basic things. And when you type equations, some like shortcuts would help a lot. For example, so this will backslash alpha will return to alpha. and say backslash beta will give you beta. Like if you are familiar with the licks, then like you get to memorize a lot of shortcuts like right arrow, something like this, right? Like greater than or equal to GEQ, something like this. So, but if you do not memorize them, that's not a problem. Of course, you can choose them from here. You can learn the shortcut by placing cursor here. So when I use the transpose notation that I use is this one. So like for example, so this is how I type backslash tab uh, this is my notation, how I type the linear regression equation. Okay, this was just basic thing. You can skip this if if you're not interested. Okay, like change it to standard. Okay, so now back to homework 4. In the first question of homework 4, we'd like to study what happens when the number of instruments is the same as the number of regressors. Let me, oh, where is the cursor? Yeah. Let me show you. We have the standard linear regression, and we have instrument like X regressor is k by 1, but the instrument is also k by 1. So we have exact number of regressors. In this case, as I explained in the lecture, uh, we have k number of equations for k number of unknowns. So we have exact number of equations and unknowns. So let's see what happens. And I will put the homework question on my side. So you may want to look at the homework question um, like while I explain, right? So this is the setup. And question A. By the way, when I put numbering, I choose right description like here A and space. Then automatically A the object is in bold and in bold face, and you can type the main text from there. So construct the moment function GF for the GMM estimation. It should be simple, right? So you know the starting point is this exogeneity condition, okay? But as I said, the exogeneity condition is the basis of our estimation, but Z is not observed. So we have to replace Z with observed, excuse me, observed variables and parameter, okay? This is the exogeneity condition. So we have, if you define a function of beta uh, in this way, so then we get, I mean, like this. So here, digression, it is important that, so here I use beta 0, but this is beta. As I mentioned earlier, maybe in class, uh, epsilon, this equals to epsilon only when beta is beta 0. Epsilon is the residual, the error term defined this way. So if beta is different from the true value, this part is not epsilon, okay? So here, this is true only when beta is beta 0. But this is just a function. Here, this beta, this g of beta is a function of beta. So if you plug in different value of beta, then it will take different values. But in the end, I'll show that the function beta, g beta, will be expectedly 0 only when beta equals beta 0. So I want you to see the relationship between the difference between beta and beta 0. You know, this is the moment function. And B, suppose that a symmetric and positive definite k by k weighting matrix W is given, right? And then how can you set up GMM objective function? Let me just, exactly, it's a textbook. Uh, you can just write this way. Okay, let me use subscript I. So I should have used subscript I so that it's clear it is only for I's observation, right? So, or to be more correct, you can right. You can write this way. This is sample average of the moment function, and then the GMM objective function like this. We are going to minimize this quadratic form function. Okay, of course W is k by k weighting matrix. Simple up to here, just same as lecture note. Derive the first order condition for the GMM minimization problem. Show that the closed form solution for beta is complicated. Okay, let's see. Uh, so this is a kind of quadratic function. Remember, it's like, for example, in scalar case, uh, if you to differentiate, like say w times f b squared with respect to, then we get w times 2 times w times fb times f prime b, right? It is what is the name of this? Like chain rule. You know how to differentiate that, and we are going to do the same way. But the difference here is, uh, here in scalar case, we do not care about the order. What is multiplied first and what is multiplied later? That does not matter. But now we have to think about that. But in a vector case, we have 2 times hat g and beta w hat g and beta. Okay, structure is the same. We have to multiply 2 because 2 is here, and we have to differentiate one of them, but we put it in front, right? And in back we get the same g, because so the last g is this guy, the first capital G is this guy. So now the order matters. In the vector notation, order matters, and this is the derivative of the GMM objective function is this one. And then, so this is just a derivative. The first order condition is that the derivative function equals 0 when beta is beta 0. Okay, so this is what we know. So I will simply drop 2. 2 does not matter because, let me finish it up. 2 does not matter because anyhow it will be divided by 2, then will easily gone. So this is what you get. And from here, I believe it is not that difficult, right? Even though it will be annoying, a little bit annoying, but from here you can plug in what is the derivative. Like, okay, so you can calculate, think about this here, right? So the derivative of G is like beta is here, it's linear in beta, so it is pretty simple. This is it, right? So we are going to differentiate this guy with respect to beta. So then this is constant, y term goes away, and z times x transpose, but there is a minus sign, so minus goes in front. So this is what we get. Then you plug this much into here with, anyhow, it does not depend on beta, so simple. And beta hat depends only on here. By the way, excuse me, I should have written this way. Oh. So because this is simple estimator, the first order condition is satisfied at the estimator. So we have, anyhow. So then if you plug this back into here, the whole left-hand side of the first order condition has only one beta in here because this part does not depend on beta. So beta hat is in here, and that is linear. So it should be pretty easy to rearrange the linear equation, linear equality, to obtain the closed form solution in the question. So I believe it should be doable, not much like it should be simple enough. Okay. Okay, then think about D. By the full rank assumption, this is invariable. W is also invariable because so full rank assumption. This is invariable. Let me briefly mention why this is invariable. So we like analogy again. So think about in scalar case, think about AN converges to C such that C is not zero, right? Suppose that there is a sequence of numbers converges to a constant C, and the constant is not zero. Then we can say that AN won't be zero, right? If N is sufficiently large, right? So in the end, we know that A and the sequence will converge to say 0.1, close to zero, but definitely different from zero. So then anyhow, from some point, it should be close enough to 0.1. That means it should be different from zero. So in that sense, what we have here is assumption, full rank assumption is, so in our case, full rank assumption means the determinant of expectation xi zi prime, or the other way, the same, is not zero, and we know that determinant of the sample average converges in probability, but let me just put it as it is, converges to this guy, which is not zero. Okay, so we can say that the sample average has non-zero determinant, which means invariable if n is sufficiently large. So that is why we can like say this sample average is invariable from the assumption of the population. Okay, the population mean is invariable, then because the determinant function is continuous, and the sample average will converge in probability to the true population mean. So in the end, the sample mean will be also invariable if sample size is large enough. Anyhow, this is what you get. And this question is, if you understand this, it should be really, really easy. I think I can just skip that. Like, I showed you the closed form solution from C. So, and I already give you the idea of ABC inverse is C inverse, B inverse, A inverse. Combine them, then you will get the answer. So, it's super simple. Okay, what you are going to get. Okay, so next, okay, so in this, from part B, I just stopped calculating the GMM from the first order condition. Like, so I did not think about the optimal weight, right? So, but I showed, anyhow, the weighting matrix does not matter in the end in part D. But what happens if you just continue doing that, and if you find the optimal GMM matrix, then what will be the variance matrix? Again, the weighting matrix does not matter. The weighting matrix does not affect the variance, because like, we know that the asymptotic variance of a GMM estimator is given by, like, say, V equals G transpose WG inverse G transpose W omega, I think omega, right? Oh yeah, omega, right? WG G transpose WG inverse, something like this. And we are going to apply the same result again. ABC inverse equals C inverse, B inverse, A inverse, right? In this special case, you have to show that first, you have to realize that G is invariable. That's exactly what I explained here. Because G is invariable, W is invariable, everything is easily invariable, then everything will be canceled out, so you get what you want. Okay, so this is end of question 1, right? And I want you to get the intuition here. Weighting matrix matters only when you have extra information. So that's how I motivated the GMM method. But in this case, as you see in this example, when you have exact number of instruments for the same number of regressors, you don't need to worry about weight. Okay. Okay. In the next video, I will discuss the second question. Thank you for watching.